guys, welcome to my channel. In this video, we're going to calculate the live load reduction of a beam. This is a very common FE Civil question. If you guys like this video, please give me a big thumbs up. Don't forget to subscribe and let's get started. Oh yeah, everybody now. Okay guys, so I actually didn't get a question like this on my FE exam because I think I took it like a couple years ago, but recently a lot of my students has told me that they've been getting this type of question, and that's why I wanted to share it with you guys to make sure that you are ready for your test. Okay, so we are giving a 50 feet by 30 feet slab, dead load 75, live load of 50, the tributary area is 20 feet by 25 feet, and we need to calculate the live load reduction for the beam, and it has a span of 30 feet. So the first thing you probably would do is type in live load reduction, or maybe just like live load, or just remember that I covered it, and then it's going to be on structural design section, and it's going to be on page 158. Okay guys, so before I actually start talking about these equations, I just want to mention something. We never reduced the dead load. So this 75 PSF was just giving to kind of throw you off. So we don't care about dead load in this type of problem. What is dead load? So dead load is the material of like what your beam is constructed of, your column or your slab. So you can't really reduce that because whatever you built with, that's your dead load, right? But the live load, because sometimes we tend to over design, like for example, here we were giving live load of 50 PSF, and that's usually for an office. For residential, you get a live load of like 40 PSF, and 50 PSF, that means you have 50 pounds per foot squared, and there's less likely the chance for that happening, and so that is a little bit over designing, and so that's why we reduce it a little bit, but not too much. So there's a way how, like if you reduce it too much, this equation tells you, hey, no, you can't do that. That's too much. This is your limit. So we'll go over that in a little bit. So these are the two equations. The first one is for if it's supporting one floor. The second one if it's supporting two or more floors. The only difference between these two equations is actually this inequality here. But everything else here is the same. So if you have one floor, this has to be greater or equal to 0.5 of your live load. Make sure you guys always check this inequality here. It's really important. Or if your member is supporting two or more floors, then this has to be greater or equal to 0.4 live load. What that means is that you don't want to reduce it more than 0.4 times your live load, or you don't want to reduce it more than 0.5 live load, because then you're probably going to be under designing. So another thing I would like to talk about is the A. That's the area, but it's the tributary area, meaning just the area that's going to be carried by that member. So that's usually in the FE exam, they give you that. You don't have to really find what the tributary area. If you guys want to know how we actually calculate the tributary area, giving like a dimension for a slab, let me know in the comments below, and I'll make you guys a video on that. And then you have the KLL, which is the ratio of area of influence. Depends on what you have. If you have a column, you use 4, and if you have a beam or a girder, you use 2. So that's it for this equation. So let's write it down, and then we can start plugging in the numbers. Here, since it didn't say if it's supporting one or two floors, we're just going to assume that it's supporting one floor, and we're just going to use this equation right here. Okay, so let's write the equation down. Okay guys, so the nominal live load is just the live load that we have, which is 50 PSF, meaning before we reduced it or we've done anything to it. If you go to the code, you will see that for live load for an office, usually it's 50 PSF. So KL here, it does specify that we have a beam, so we're going to use 2. So we're going to use, 2. So I have 2 here. And then the area, so make sure you don't use the area for the slab, you use the tributary area, which is 20 by 25. Again, let me explain that real quick here. So the slab was giving as 50 by 30 feet. That's the area for the whole slab. But the beam, it's only carrying 20 feet by 20 feet. That's how much load is going to that beam. So that's the tributary area. And that's it. So just plug in your numbers, and we're going to get about 36 PSF. So the answer is going to be B, but we're not done yet. we have to check this inequality, guys. So this, we gotta make sure, is it greater than or equal to 0.5 times your nominal live load, or just the giving live load. So this is going to be 0.5 times 50, which equals to 25, right? This is greater than 25, so we are okay. A couple of my students, they had a question where when they calculated for the live load reduction, this was actually smaller than 25. So in that case, you have to just pick 25 as your answer. So I hope that makes sense, guys. Let me know if you have any questions in the comments below. Okay, guys, so that will be it for today's video. On the next time, we're going to calculate the peak discharge for a watershed. This is more like a hydrology question. If you guys want to see more videos, don't forget to subscribe. If you like this video, please give me a big thumbs up. Thank you guys for watching, and I will see you soon. À la prochaine.